This presentation covers graphing and visual representations of data. It's a follow-up from the previous material on collecting data and observing behavior. As with all these presentations, it's going to be more effective and more useful to you if you read the chapter on graphing in the text first, print out a copy of the PowerPoint notes, and then take notes as you watch the presentation. Graphing is extremely useful. It has a long history with behavior analysts and people who have been interested in measuring behavior. Graphs accomplish a great deal with a minimal amount of effort. That's a way to convey an enormous amount of information visually, so it's very effective in communicating with other people. It's also really useful as you're collecting data and you use that data to make decisions about interventions. You're able to know on a day-to-day basis the direction of any change in behavior. So, first of all, we'll talk about establishing baseline and what that means, and then we'll talk about using data to check for or monitor progress. Baseline refers to a measure of behavior before you do some kind of intervention. So, if your purpose is to teach a new skill, you want to collect baseline data so that you have a basis for comparison and you can determine if the student's actually learning the skill that you are teaching. If your goal is to reduce a challenging behavior, you need baseline data to compare with your intervention data so that you know if your intervention is working. You don't want to spend time and energy on interventions that are not accomplishing what they were designed to do. Also, baseline data gives you very valuable information for developing interventions, and we'll spend some time later on talking about different ways to use information, different ways to gather information. Just as a review, let's talk about some of the different types of data and the kinds of behavior that we would be measuring with these data. We talked about two basic categories of data collection: event recording and estimating tactics. With event recording, we are directly measuring a behavior. The way we measure it is determined by the nature of the behavior itself and what's important. What are we really interested in measuring? So with event recording, we might have frequency recording, just counting the number of times a behavior occurs. We do that when it's not really that relevant how long each incident lasts. For instance, if a kid is saying inappropriate words, it might not be as important to talk about how long each word takes, but it's more important the number of times. However, if a student is having a tantrum, it's more relevant to know how long each tantrum lasts. For example, a kid could have 2 tantrums, but if 2 tantrums last 5 minutes each, that's very different from 2 tantrums that last 30 minutes each. In that situation, we would want to use duration recording. Another variant of frequency data is permanent product recording. This is when you're actually looking at the product of a behavior, not the behavior itself. So it might be the number of math items, problems worked correctly on a worksheet. Trial recording has to do with when we collect data on a student's response to discrete trials. So in other words, a spelling test is a form of discrete trial. I call out 10 words. Each time I call out a word, the student writes down the word, and then we're looking at recording whether or not the student spelled the word correctly or incorrectly. And if you didn't notice, that sort of has an overlap with permanent product recording in the example I gave. That's very common with these data collection procedures. Sometimes we're sort of mixing 2 of them together. For example, with duration recording, I might want to know how long each tantrum lasts, but I also want to know how many tantrums, so I'm going to collect frequency data and duration data. Task analysis recording has to do with the data we would collect from teaching a behavioral chain. For example, if I was teaching a student to make a smoothie, I have a task analysis and I'm recording the level of independence the student shows on each step in that task analysis. Estimating procedures, the next category, are ways of collecting data that give us estimates, but they don't directly measure a behavior. They're also extremely useful in some situations. Interval recording has several variations. There's partial interval and whole interval recording that we discussed in our data collection section. Momentary time sampling is one that's extremely useful, and that's one that you'll probably use a lot. It is a way of estimating duration or prevalence of a behavior. So it's not that useful for something that you would really measure by frequency, like aggression or swear words, but it's very useful if you want to measure something like on-task behavior, or if you want to estimate the amount of time that a student with autism is appropriately interacting with peers. So if you're still a little bit unclear, it would be really important to review this material at this point. Go back and look at event recording, look at estimating. Be sure that you have a very clear understanding of when you would use which method of recording. Once we collect data, it's the way that we organize and summarize the information is going to make that data useful to us, or it's going to make it something that's just something to collect on a computer hard drive or a file folder. It's important anytime you're going to collect data, think ahead to how you are going to use that data. If it's not clear to you how you're going to use something, then you really should consider if it's data that you need to spend your time collecting. The point is that any kind of data needs to have a purpose, and one of those primary purposes is you want to use it to evaluate whether or not an intervention is working. You also want to use it as a way to make decisions about the best interventions for your student. There's some basic concepts for summarizing data. Sometimes we use measures of central tendency, and two very common measures there are the mean, or the average, or the median, or the middle value. Those are both ways to describe a group of numbers. So what you're doing is you're taking several numbers, there might be 12 numbers in the set, and you're representing those with one number. The key here is what number best represents that whole batch. Very often we use the mean, but I'm going to give you some examples that show that in some situations the median or middle score might be a better tool. Another very useful measure is the range. The range is the difference from the highest score to the lowest score. That gives you an idea of how the score is spread out. Got ahead of myself. First day we had a frequency of 4. The next day we had a frequency of 7, then 3, 5, and 1. Well, if we average these together, these add up to 20. We divide by 5 days. So our average score is 4. And we do have one score that's a 4. The median score, if we take our number of occurrences each day and we find the middle value, the median score is going to be 4. The way you find a median is you take your numbers, and these are the same numbers by the way in these two columns. To find the median, you arrange them in either ascending or descending order, it doesn't really matter which, and you just find the score that's in the middle. If you have an odd number of scores, then the middle value is going to be between two scores. If you have an even number, the middle value is going to be between two scores. We have an odd number because we have 5 days, so the middle value is 4. So this is our actual middle score. So the question is, which of these represents this set of data better? The middle value of 4 or the mean of 4? Well, in this case it doesn't matter because it's the same value. The range is 6 because we had a high score of 7, the lowest score of 1. The difference between those is 6, and that gives you an idea of how these scores spread out. Okay, now let's look at a different example. In the previous one, the scores had a range of 6. and the median and the mean were very similar. What happens, however, when you have an extreme score? In this case, on the 5th day, we have a frequency of 31. That's very different from these other scores. If we take the mean, we're now taking a total of 50 and dividing it by 5. Our mean is now 10. Okay. The median, however, is still 4 because the 4 is still the score in the middle. This shows us a characteristic of the mean. The mean is affected by extreme scores much more so than the median. So that's why these are both useful measures to have. This mean of 10 doesn't represent these scores that much because we don't even have a score of 10. It is being skewed by this extreme score. So when you have a range that's really high, you want to look at the median as well as just the mean. So always look at the range. I generally use both of them. Okay, this is an example of some data of a student hitting. And just to take a look at this graph, we have two axes. We have this vertical axis or the y-axis. This shows the level of a behavior, and it's always labeled to tell us the type of measurement that we're using. Then we have the horizontal axis. This is the x-axis. This is usually some unit of time, and it's labeled to tell us exactly what unit of time we're talking about. We could be talking about days, we could be talking about weeks, we could be talking about months. Usually with students and behavioral data, we talk about data across days. So this is showing our students' data represented on a graph for each day. This is the same data that we had earlier, but it looks a little different now. This is an example of some data with an extreme score. So we have this score up here, this 31, that's very different from these other scores. This stands out on a visual graph in a way that it doesn't stand out in a column of numbers, I think. So, what's the purpose of graphing? Well, after a functional behavior assessment, it's useful to graph our data because we're going to be implementing some kind of intervention usually. We want to be able to monitor our students' progress. We want to be able to show if the behavior is increasing, decreasing, or if it's staying the same. If it's a behavior that is occurring too often and it's a problem behavior, we want to see this behavior decreasing. If it's increasing or staying the same, it means we need to change something. So this is a way for us to evaluate the effectiveness of our intervention. It also is a way for us to confirm a hypothesis we might have about the function of a behavior. We'll be talking a lot more about that later on. A hypothesis is a theory that we have that's based on the data that we've got. And our hypothesis, for example, for a function might be that this behavior is occurring to obtain the teacher's attention. In other words, that's why the student engages in this behavior. So by graphing our data, if we base our intervention on this hypothesis that the behavior is happening to get the teacher's attention, and then we don't see the behavior changing, it means we might have been wrong, and we want to change our intervention. The style of graphs that we were just looking at in the last example are called line graphs. They differ from other kinds of graphs like bar graphs or pie charts because they show a behavior occurring over time. One of the uses that we're going to have for this kind of graph is to chart behavior from one day to the next or from one week to the next so that we can make some statement about direction of change in the behavior. So the purpose of the line graph, as far as we're concerned, is to chart a behavior over time. Behavior is an indication of learning. In other words, we're looking at the student's behavior giving us an indication of what that person has learned. Behavior analysts define learning in a very special way. We call learning a relatively permanent change in behavior over time. That means that for us, in order to say that learning has occurred, we need to see a change in behavior. And relatively permanent means that it's a change in behavior that goes beyond 1 or 2 days. In other words, we've changed the way that this person interacts with the environment. Line graphs show a number of different things. Usually they show us the daily amount of behavior. The amount or the number on the graph is going to be determined by the way we measure the behavior. If we were talking about something like duration, then our graph is going to show amount of time or percentage of time. If our data is based on frequency or the number of times a behavior occurred, our graph is going to show frequency of behavior per day. It also is going to indicate any changes in conditions or changes in the intervention. On a graph, we indicate that by a vertical line that's drawn during the graph, and we'll look at some examples of those, and it's called a phase change line. So if you want to indicate a change that you did on a graph, you draw a vertical line that separates the data points, and then you label it with the type of change that you made. It also shows if you've had any decrease or increase in a behavior. Obviously, what you're looking for is changes in behavior that correspond to changes in intervention that you made. So it's a way of verifying if your intervention has caused a change in the student's behavior. And a picture is worth 1,000 words. What we mean by that is a graph makes it very clear if your intervention is or is not having the effect you wanted it to have. Again, as I said earlier, it communicates an enormous amount of information visually. The different parts of a graph that you need to be aware of, there are 2 axes. There is the vertical axis or the y-axis. This shows the amount of behavior. The horizontal axis or the x-axis, this shows the behavior over time. So it's usually labeled with sessions or days or weeks. Tick marks are the little notches on each of the axes that shows the unit of measurement. In other words, it shows the difference between a 1 and a 2 or a 3 and a 4. Here's an example of a graph with all the parts labeled. So we have our y-axis, and these are tick marks, and the values associated with each of those are indicated as well. The unit of measure is always clearly marked. This graph would mean something very different if these were hours engaging in a behavior versus the number of times the behavior occurred. So these labels allow us to interpret the graph. The x-axis is labeled days. This is the unit of time. And these are the data points. These are the individual values of behavior. The line connecting the data points is called the data path. You can have more than one of these on a graph. 2 is pretty common if you have 2 behaviors you're measuring. Sometimes 3. I typically don't like to put more than 3 of these data paths on a graph, because then the graph becomes very hard to interpret visually. Some other components. The origin is the starting point for the 2 axes. So it's the point in the corner where the x-axis and y-axes meet. The data points are the individual totals of behavior per unit of time, so it would be the number of times or the amount of time per day. And then the data path, as we indicated, is the lines connecting the data points. And this is just a label graph to go over each of those points. A condition or a phase label and phase change lines help you know when you've changed something. So one phase change line or condition change that you're going to see all the time is between baseline and intervention. You indicate that always with a solid vertical line. Also, if you take a look at the graph, sorry about that. There are some other things that are important to graph. One of them is called a trend line. When we look at data on a graph, we want to make a statement about whether overall the student's behavior is increasing, decreasing, or staying about the same. We call this trend. So we want to make a statement about the trend of a behavior. What this does is it helps us predict how this learner might behave in the future, or it helps us evaluate where our intervention might be going. Sometimes it also helps us know whether or not we need to implement an intervention. If I'm collecting baseline data and I have a trend line that is decreasing, and it's a behavior that I'm concerned about, if the behavior is already going down, maybe this isn't the time to implement that intervention. Maybe I'm better off spending my energy on something else since it's decreasing anyway. So let's take an example. We have a student who is hitting peers, and we're measuring the frequency of that each day. So we've got 6 days of data. Okay, visually looking at these numbers, is the behavior getting worse, getting better, or is it staying about the same? Well, you can make some statement about that by looking at the numbers. However, if you put this on a graph, it makes it a lot easier to see and to visualize. So the question is, and this is what we want to answer with a trend line, if I don't change anything, what can I expect to happen over the behavior over the next few days? Do I expect that it's going to keep increasing? Do I expect that it's going to decrease? Or do I expect it's going to stay the same? Well, the first step is to graph the data and take a look at it. So if we look at these data, is this going up, is it going down, or is it staying about the same? Well, of course it's going up, and it's very clear in this case. However, sometimes when we graph data, it bounces around so much that it's hard to make a clear statement about whether it's going up or down. That's when some other tools become useful. There's a technique that we're going to use, and we'll use it with this simple example to draw a trend line, and it's called the standard quarter intersect method. It sounds kind of complicated. It's actually not very difficult, but it involves drawing some temporary lines on the graph and using them to draw a trend line. So the first step into this is we take the data, so we take the graph we were just looking at, and we divide it in half. So we draw this line, and we would actually do this in pencil because we're going to be erasing it later. We've got 6 data points, so the middle here is between day 4 and day 5. Obviously, if I had an odd number of data points, my middle point would be on top of a data. My middle point would be on top of a data point. Since we have an even number, it's between 2. So I find the middle day, it's between 3 and 4. Once I've found the middle point for the whole series of data, I want to look at each half separately. For each of those halves, I want to find the middle day. So I want to find the middle day for the first half, and I want to find the middle day for the second half. I'm going to indicate that with a dotted vertical line on the graph, and again, I'm going to do that in pencil because these are only temporary lines. These dotted lines are going to divide my graph into quarters, which is why we're calling this the quarter intersect method. Okay, so here I've first divided my entire graph in half. Now for each half I have 3 data points, and since I have an odd number of data points, the middle one is going to be on top of a data point. So the middle data point is here for this half, the middle data point is here for this half. If I had had 4 data points in each half, the middle point would be between 2 as it is here. But we have a middle point for the first half, middle point for the second half. The next step is I want to find the middle value for each half. So I want to find the median, in other words. This is easiest to do if I just take the values of the data points and I arrange them in ascending order, and I find the middle value for each half. It's a lot easier if you see it. So the middle value of these 3, I really don't have to arrange. I know that this is the highest value, this is the lowest value, and this is the middle value. Here, the middle value is this data point, because obviously this is the highest, this is the lowest, and this is the middle. So with 3 data points, it's pretty easy. At this point, I want to take the middle value and project it across till it intersects with the middle line here. I want to do the same thing over here. So in other words, the middle value for that section of the graph or that quarter intersects with the quarter line here. Now what I'm going to be doing next is making an X here and making an X here and connecting these 2 lines. That's going to become my trend line. So I mark the points for the line, I connect it with a line, I draw a line, and that becomes my line of prediction. So what this has done, then of course now I can erase all of these, I can erase all of this stuff, and all I'm going to have left is my data point, my data path, and my trend line. You can do the same thing mathematically by using a line of regression, and Microsoft Excel actually allows you to calculate that. However, with a little practice, you can do this procedure really quickly, and I found that it's very close to the trend line that's calculated by Excel. So if you draw your graphs by hand, which is often a convenient way to do it, this is a good way to draw trend lines. Here's another example of some data. This is 7 days of data, so you have an odd number of data points. What I would suggest you do right now is graph these data on a sheet of graph paper. Practice yourself using the standard quarter intersect method to draw a trend line. Once you've drawn a trend line yourself, then proceed with the PowerPoint, proceed with the recording here, and check your work. The easiest way to get good at this is just to practice it some. It's not that difficult, but it does involve a sequence of steps you have to get in the right order. So pause the recording at this point, graph this up, and try it yourself. Okay, how did your graph work out? Let's take a look. First of all, your graph should look something like this. Now, if you have to make a statement about this data and how it looks different from the other example, what would you say about the extent to which it bounces around? Well, it's obviously a lot more bouncy. We call this variability. These data are much more variable than the previous examples. And you can also see that it's a little bit harder to see trend in these data. So drawing a trend line becomes more important. If we're going to draw a trend line, what's our first step? Well, we have to find the middle value, and we draw a solid vertical line in pencil where that middle value is. And it would be on this data point, because again we started with an odd number, so our middle point is actually resting on top of one of our data points. What's the next step? Well, we want to find the middle day for each part of the graph. Even though we had 7 data points in this case, we still have 3 data points in each half because this middle one doesn't really belong in either half. So we'll locate the middle data points, which is going to be this point and this point. The next step is, of course, we find the middle value. So we rule out the lowest and highest score, and we find the middle value for this half. We do the same thing over here. The middle value for this part happens to also be the middle score in terms of days, so that makes that a little easier. Next, we draw the horizontal lines to connect the middle value with the quarter mark. We do that in both places, and then we indicate where our trend line will intersect, and then we draw our trend line, and voila, there we go. So this makes it a little clearer to us that we have a trend that's going up with these data, even though they're a little more variable. Now let's shift gears and let's review how we would use graphs to monitor a student's progress. The first step is we have to establish some kind of baseline level of performance. In other words, what does the student's behavior look like when no intervention is in place? Often people who are not in the field don't understand why we want to collect several days of data before we implement some kind of intervention. The reason is almost always it allows us to implement a better intervention. We're going to use that information to design something that is really geared to what the student needs. It also is going to allow us to know with a lot of certainty whether the intervention we've developed is actually doing what we wanted it to do. You generally want at least 3 days of data. 5 is better, but sometimes if the data is really stable, in other words, it's not bouncing around a lot, we can go ahead and implement after 3 days. Sometimes we need 5 days. It's worth the extra couple of days of data collection, almost always. The exception would be if this was a very dangerous behavior, if it's something that is causing people to get hurt. Certainly we want to put some safety measures in right away, but usually we don't want to collect a lot of baseline data when we really need to develop an intervention quickly. After we collect some data, we want to draw a trend line. The trend line we just reviewed, that is a way of telling us if the behavior is increasing, decreasing, or staying the same. If it's an appropriate behavior, obviously we want it to increase. If it's a problem behavior, this is something we want to decrease. So in baseline, what's happening? What's the direction of behavior change? The next thing we want to do is determine a reasonable goal. How much do we think the behavior needs to increase or decrease? And what's the time frame? What's a reasonable goal by which to have achieved this level of behavior? It's sort of an arbitrary decision sometimes, but sometimes there are real timelines put into place. For example, if I'm working with a student who's going to be transitioning to another classroom at the end of the school year, and I know that I need to have this student's behavior at a certain level that would be acceptable in that next environment, then I'm going to put that on the graph, and that's my goal. It's called an aim star or just an aim mark. We usually indicate that on a graph with a letter A. To be honest with you, I don't always put an aim star on my graphs. They can be useful in some situations, especially if you're working against a very specific timeline. So let's take the example. Let's say we've got 6 days of data, and we're looking at completion of a task. So here are the number of tasks the student completed for each of those 6 days. Then we have 6 additional days of data with the number of tasks completed. So our graph here, we have the y-axis and the x-axis. We have frequency of task completion. We have 6 days of data in baseline. We implemented a behavioral contract on day 7. So we're drawing a phase change line, and then we're labeling each phase of the graph. Here we have the number of tasks completed after the intervention was put into effect. And if we drew a trend line through this, we'd see that this is an ascending trend. That means the trend is going up. But let's say that we know that by this date the student needs to be at a level of completing 18 tasks per day, because maybe that's the requirement of the environment where the student's going. So here's the question. If the student's behavior continues the way it's going right now, will that student reach this goal by this date? And how do we answer that question? The easiest way is to draw a trend line. So we draw a trend line just to determine if the line crosses that goal. So to review, if it's clear that the student's going to meet the goal by the time, then no change is indicated in the intervention. If it's clear that the student's not going to meet that goal, then we've got some decisions to make. One of them might be that we change the goal, and we're just saying that, well, this student's making really good progress, but probably is not going to meet the goal by this date. Sometimes we don't have that option. Sometimes it's an opportunity that might be really good for the student, and it's really important to meet the goal by that date. Then we have to consider, are there changes we can make to the intervention that might make it more effective? If we do change something, then we draw a phase change line on the graph to indicate we made a change. If we decide to change the intervention, we draw a phase change line, then we need at least 3 to 5 days of data before we can make a determination as to whether our change in intervention is having effect on the student's behavior. Just like in baseline, we can't base that on 1 or 2 days. We need several points of observation. So we want to graph our data as it's being collected, and then we're going to use different criteria to evaluate whether or not the learner is making progress. First thing we're going to look for is something called change in level. In other words, if we take the data points within that phase and we average them, how does it compare to the average during baseline or during the previous phase of intervention, the data before we made our change? Then we're going to look at something called the amount of overlap. How many data points in this new phase overlap with data points in the previous phase? If there's a lot of overlap, it means there's not a lot of change in behavior. Then we look at change in trend. Change is the direction in the behavior. Is the trend line going up? Is it going down? Or is it neutral, going straight across? And then we compare the learner's progress with our goal or aim, and we ask the question, is the goal going to be met now? So let's talk about each of these individually. Level is the amount of behavior. We're interested in the immediacy of change as well. If it's a powerful intervention, it's going to have an impact on the behavior pretty quickly. So one way of comparing level is you take the last day of baseline and you subtract the last day of baseline from the first day of intervention. The greater the change in level, the more powerful the intervention. So in this instance, immediacy of effect would be the difference between the last day of baseline and the first day of intervention. So in this case, we have our last day of baseline here, and we have our first day of intervention here. So we had an immediate change in level of 3. We went from 3 to 6. And another way to look at this is we get the average of these numbers and the average of these numbers. I generally like to do both of those things. Next thing I want to look at is overlap. If I look at the range of data in baseline and the range of data in my intervention, what percentage of those data points overlap with one another? If there's less overlap, it means I have a more powerful intervention. Look at my range here. This is my lowest data point and my highest data point. I extend a horizontal line out across my intervention to encompass the range, and then I look at the percentage of data points that fall within that. So 3 of these 6 data points fall within this, so I have 50% overlap. Well, if I change my intervention, draw another phase change line, I want to look at the percentage of overlap there with baseline. If I get a number close to this, it's going to indicate that I don't have a lot of change in my behavior. Once we look at overlap, the next thing we look at is trend. Is there a change in trend from one phase of the graph to another? First thing we have to do is we have to draw a trend line. So we use the method we discussed previously. We draw a trend line, and then we consider what was the previous trend. Was the trend ascending, descending, or neutral? Ascending means it's going up, descending means it's going down, neutral means it's sort of horizontal. Do we see a change in direction of trend when we go from one phase of the graph to another? The next question is, if we have our aim line drawn, or we have our aim star drawn, does our trend line show that we're going to meet the goal by the date that we need to? So here's an example. We have baseline data and we have intervention data. We use the quarter intersect method to draw a trend line through baseline. Okay, if you look at this trend, would you describe it as ascending, descending, or neutral? It's neutral because it's staying pretty horizontal. Here we draw a trend line again using the quarter intersect method for these data. Is this trend line ascending, descending, or neutral? The trend is ascending. Does this trend line project that we're going to meet our goal by the date we've indicated? And the answer to that is yes. In fact, this trend line would have us meeting the goal before the actual date. So this would certainly indicate that we don't need to make any change in our intervention, that our students progressing the way that we think, and that our goal that we had established is actually something reasonable. The minimum acceleration line. Some people will use this term to describe the line that we've drawn previously. Essentially what it means is this: if the student's behavior is above that line, it indicates that the student's going to meet the goal by the date you've indicated. If the student's behavior is falling below that line, then the student's not going to meet the goal. Of course, this is if it's the behavior you want to decrease. If it's the behavior you want to decrease, you sort of flip that around. It makes it easier to look at an example. So our minimum acceleration line is drawn here. Is the student's performance above or below the line? Well, it's right on the line here, so you can't say with a lot of confidence the student's going to meet the goal, but probably would meet the goal. Personally, I don't use minimum acceleration lines that much.